We're going to talk about some Boolean operators we can use in our if statements and while loops to create compound conditions. So this is an example of what a compound condition looks like. We have two conditions and then some weird symbols in between them. This is going to evaluate to true or false is a Boolean expression. What do you think will make this evaluate to true? So when will this entire condition be true? Think about that, and then just tell me, what do you think? Sounds about right. This means and, so this will be true. This entire expression will be true if both there's a flower ahead of Bob and there's water to Bob's left. So in this example, we have a flower in front of Bob and water to his left, so this condition would be true. If only one of these things was there, if only a flower was there or only the water was there or neither was there, then this would evaluate to false. How about this? When will this expression be true? So we've changed what that funny symbol is between the two Boolean expressions. What will make this evaluate to true? So this means or, and there's a couple, let me get out of the way, there's a couple situations. So if either there's a flower ahead of Bob or there's water to his left or both, then this will evaluate to true. So way over there, there's water to his left, or there's a flower in front of him, or there's both water and a flower. In any of these three situations, the or compound conditional will be true. And this works just like you would, in English, right? For this one, if there's a flower and there's water, this is true. Both of them have to be there. And this means or. So if there's a flower or there's water, if there's a flower or there's water, it will be true. So, just like in English, we just use funny symbols for that. What about this? So there's an exclamation mark in front of this condition. What do you think this does? When will this evaluate to be true? So this means not. The exclamation mark means not. So this is actually saying not Bob is flower ahead, or is there not a flower ahead of Bob? So in any of these situations where the thing in front of Bob is not a flower, it could be water, it could be a net, it could be nothing, then it is true. But in the case where there is a flower in front of Bob, it will be false because we want to know when this is not true. So that's what the exclamation mark does. If you remember back to the last class, we talked about nesting if statements. So you can put an if statement inside of another if statement. And when you do that, both conditions need to be true in order to run that body. There has to be a net ahead of Sam, and Sam has to have a flower. And if both of those are true, Sam will toss the flower. That's one way to write this kind of code. But you can also do that with the and symbol. So this does the same thing. If Sam dot is not ahead and Sam dot has flower, then Sam will toss. So this is effectively the same as nesting two if statements with a little less typing. The and symbol you get, it's called the ampersand symbol, and you shift in the 7 key to get that symbol, and we type it twice. So 2 ampersands means and in the computer. And this will be true if both of these conditions are true. If there's an and, he has a flower. So another thing we can do with else statements, this one's a little awkward, but in this case, if it's clear ahead of Jenny, she will hop. Otherwise, if it's not clear, then we check if Jenny has a flower. And if Jenny has a flower, she will hop. So this is saying if it's clear, Jenny will hop, or if she has a flower, she will hop. Okay? And instead of writing all of this, you could just put an or symbol. If it's clear ahead of Jenny or she has a flower, Jenny will hop. And this symbol is over on the side of your keyboard. It's going to be above the enter key. And again, you hold the shift key and you push that and you get a little bar. And we do it twice to get 2 bars, which means or. And then another awkward thing you can write in code is you can have an if statement with nothing in the body. So if Paul.isClear ahead, if it's clear ahead of Paul, don't do anything. Otherwise, turn Paul left. So what this is saying is you're only going to do something if this condition is false. So if it's not clear in front of Paul, then turn left. And there's a much easier way to write that, which is just with the not symbol, with the exclamation mark. So if not Paul is clear, if exclamation Paul.isClear ahead, Paul.turn left. And the exclamation mark is above the one, the one key on the keyboard. Shift 1 will get you the exclamation mark. And that goes in front of the variable name. So not Paul.isClear. So those are our compound Boolean operators. And it's 2 ampersands, and that makes it so both conditions have to be true, or means either one of them can be true, and not means it will evaluate as true if the condition is false. So it negates whatever the condition is. It's the opposite. And you can use these in if statements or in while loops in the condition portion of that to check multiple conditions at once. So let's look at a demo and how we can use this to solve mazes on Jeru Island. So there's kind of a trick, excuse me, to solving mazes, and that's you use a while loop and you say, while I'm not at the end of the maze, keep trying to traverse the maze. And we might have different rules for what you should do to traverse the maze. Generally, in a Jeru maze, there's going to be a flower at the end. That's how you know you've reached the end. If you're stepping on top of a flower, you've reached the end of the maze. So to solve this, and I'm just going to step 1 through here to show you. Oh, I have an error because this isn't real code. To solve this, we want to say, while I'm not at the end of the maze. So while I'm not, exclamation mark, at the end of the maze. How do I know I'm at the end of the maze? Because there's a flower right where I'm standing. So Bill, the name of my Jeru, is flower here. Let's make that lowercase l. So if there is not a flower here where Bill is standing, then we're going to do something. And for now, I'm just going to say Bill.hop. So Bill's going to hop as long as he's not standing on a flower. Once he's on a flower, he'll stop hopping. So I can run this. I get Bill. He's up there in the corner. And we're going to say, is there a flower where he's standing? No. So he hops. No flower, no flower. He just hops, keeps hopping until he gets to now he's standing on top of a flower. And the loop is done. He's made it to the end of the maze. A very simple maze, right? Walk in a straight line. Easiest kind of maze you can get. Okay, so now you can write other code in here. Before you hop, you might want to check if you have to turn. So in more complicated mazes, you might not just want to go in a straight line. Possibly, you have to turn. So let's make this a little more complicated and say, oh no, there's a turn. Oh, there's a lot of water there. Let's turn some of that into grass. And then we'll put a flower at the end. So we still say, while there's no flower here, that's how we know we're at the end. But we have to add some code to tell it, sometimes you want to turn. So not always, but sometimes. So that means you're going to use an if statement. If I need to turn, then Bill is going to turn. I'm going to say he's going to turn right. So how do I know I'm going to turn? Well, if there's water ahead of Bill, he will die if he hops into the water because Jerus can't swim. So we know that if there's water ahead of Bill, excuse me, Bill should turn. So if Bill is water ahead, then I'm going to have Bill turn right, and then he will hop. So we will, let's just run this and see. He gets there, he gets to the water, he turns. I'm going to run that slower. So he hops a bunch. All right, he gets to the water. We check, is he on the flower? No. Now we check, is there a water ahead of him? Yes, there is. So he's going to turn right, and then he's going to hop. And then we're going to check, is there a flower where he is? And then we go through this until he gets to the flower. Okay. Another thing that might happen is maybe it's more complex, and maybe there's another turn in here. let's turn this stuff into grass. Let's put our flower at the end. So now let's see if this code works for this. So Bill is gonna go forward a bunch. He's not turning yet. He gets, excuse me, to the turn. He sees the water. He turns to the right. He hops. He keeps going. He gets to the water. He sees the water. So he's going to turn to the right. Uh-oh. And then he hops into the water. So here's what happens in mazes on Drew Island. Usually a maze is going to have some way to tell whether you're turning left or right. So maybe we'll put a net if you want to turn to the left. So we can say if there's water ahead, turn right. Else, if Bill dot is net ahead, Bill dot turn left. So now if I run this, he's going to hop, hop, hop. Should have made this column a little shorter. He gets there, he turns, he hops down, he sees it's not water. Is it a net? Yes, it's a net. So he turns left and he hops, and now he continues on his way. So now, as long as we put water where he wants to turn right and a net where he wants to turn left, this maze could be as complex as we want, and this code is going to help Bill solve that maze every time. And now what these rules are for when you turn left and when you turn right are going to be different depending on the maze you're solving. But the instructions of the maze should explain what the rules are, and you just have to set up your if statements appropriately so you can solve the problem. But the trick to solving these is the while loop. The while loop is always going to be while you're not at the end, and then the body will have a bunch of if and else if statements checking we didn't really talk about else if before, but you could just make that 2 if statements. This also works. And that will make it so you solve the maze appropriately. And that is what you are going to be doing. Let's see if there's any more slides to talk about. Yeah, so you've got some labs to solve some mazes, and maybe other kinds of labs using ands and ors and nots that you're going to solve. So have fun with that. Remember, treat them like they're little puzzles, and have fun. Computer science.